In this video, I'd like to provide students with an introduction and first reading through Chapter 3 of Classical Arithmetic. Chapter 3, the topic of this chapter is on the division of number and the various definitions of the even and the odd. So what we're learning at this point in classical arithmetic, first we've learned about quantity, which is one of the 10 categories of Aristotle. Quantity is the second of the categories, and we learned that quantity divides into two different species or kinds. We have multitude, or discrete quantity, and magnitude, or continuous quantity. So quantity divides into two species, multitude and magnitude. And then multitude divides also into two species, absolute multitude and relative multitude. And in arithmetic, we're studying absolute multitude. So as we get to absolute multitude, which we can call number, now the question is, what is the next division? How does number divide? Into what classes or kinds does number divide? And this is the subject of Chapter 3, on the division of number, that is, into species. And we've already learned that the division of species, the division of number, is into even and odd. And in this chapter we're going to look at the definitions that have been proposed through history by the philosophers for the even and the odd. Chapter 3 of the Theoretic Arithmetic. The first division of number, therefore, is into the even and the odd. And the even number, indeed, is that which may be divided into two equal parts, without the intervention of unity in the middle. But the odd number is that which cannot be divided into equal parts without unity intervening in the middle. And these indeed are the common and known definitions of the even and odd. But the definition of them, according to the Pythagorean or Pythagorean discipline, is as follows. The even number is that which, under the same division, may be divided into the greatest and the least, the greatest in space and the least in quantity, according to the contrary passions of these two genera. But the odd number is that to which this cannot happen, but the natural division of it is into two unequal parts. Thus, for instance, if any given even number is divided, there is not any section greater than half so far as pertains to the space of division. But so far as pertains to quantity, there is no division less than that which is into two parts. Thus, if the even number 8 is divided into 4 and 4, there will be no other division which will produce greater parts, namely, in which both the parts will be greater. But also, there will be no other division which will divide the whole number into a less quantity, for no division is less than a section into two parts. For when a whole is separated by a triple division, the sum of the space is diminished, but the number of the division is increased. As discrete quantity, however, beginning from one term, receives an infinite increase of progression, but continued quantity, remember that's referring to magnitude, continued quantity may be diminished infinitely. The contrary to this takes place in the division of an even number. For here, the division is greatest in space, but least in quantity. In other words, the portions of continued quantity are the greatest, but the discrete quantity is the least possible. According to a more ancient mode, likewise, there is another definition of the even number, which is as follows. The even number is that which may be divided into two equal and two unequal parts, yet so that in neither division either parity will be mingled with imparity, or imparity with parity, except the binary number alone, the principle of parity, which does not receive an unequal section, because it consists of two unities. Thus, for instance, an even number, 10, may be divided into 5 and 5, which are two equals. And it may also be divided into unequal parts, as into 3 and 7. It is, however, with this condition, that when one part of the division is even, the other also is found to be even. And if one part is odd, the other part will be odd also, as is evident in the same number 10. For when it is divided into 5 and 5, or into 3 and 7, both parts in each division are odd. But if it or any other even number is divided into equal parts, as 8 into 4 and 4, and also into unequal parts, as the same 8 into 5 and 3, in the former division, both the parts are even, and in the latter both are odd. Nor can it ever be possible that when one part of the division is even, the other will be found to be odd, or that when one part is odd, the other will be even. But the odd number is that which in every division is always divided into unequal parts, so as always to exhibit both species of number. Nor is the one species ever without the other, but one belongs to parity and the other to imparity. Thus, if 7 is divided into 3 and 4, or into 5 and 2, the one portion is even, and the other odd. And the same thing is found to take place in all odd numbers. Nor in the division of the odd number can these two species, which naturally constitute the power and essence of number, be without each other. It may also be said that the odd number is that which by unity differs from the even number, either by increase or diminution. And also that the even number is that which by unity differs from the odd number, either by increase or diminution. For if unity is taken away or added to the even number, it becomes odd. Or if the same thing is done to the odd number, it immediately becomes even. Some of the ancients also said that the monad is the first of odd numbers. For the even is contrary to the odd, but the monad is either even or odd. It cannot, however, be even, for it cannot be divided into equal parts, nor, in short, does it admit of any division. The monad, therefore, is odd. And that's important to note that the number 1 is an odd number. If also the even is added to even, the whole becomes even. But if the monad is added to an even number, it makes the whole to be odd. And hence, the monad is not even, but odd. Aristotle, however, in his treatise called Pythagoric, says that the one, or unity, participates of both these natures. For being added to the odd, it makes the even, and if added to the even, makes the odd, which it would not be able to effect if it did not participate of both these natures, even and odd. And hence the one is called evenly odd. Archytas likewise is of the same opinion. The monad, therefore, is the first idea of the odd number, just as the Pythagoreans adapt the odd number to that which is definite and orderly in the world. But the indefinite duad is the first idea of the even number, and hence the Pythagoreans attribute the even number to that which is indefinite, unknown, and inordinate in the world. Hence also the duad is called indefinite, because it is not definite like the monad. The terms, however, which follow these in a continued series from unity are increased by an equal excess, for each of them surpasses the former number by the monad. But being increased, their ratios to each other are diminished. Being increased in number, their ratios to each other are diminished. Thus in the numbers 1, 2, 3, 4, 5, 6, the ratio of 2 to 1 is double, but of 3 to 2 is sesquialter, and of 4 to 3 is sesquitertian, and of 5 to 4 is sesquiquartan, and of 6 to 5 is sesquiquintan. The last ratio, however, is less than the sesquiquartan. The sesquiquartan is less than the sesquitertian. The sesquitertian than the sesquialter, and the sesquialter than the double. And the like takes place in the remaining numbers. The odd and the even numbers also, surveyed about unity, alternately succeed each other. And this is the reading of chapter 3 in classical arithmetic. So what we learn in chapter 3 is that number, or absolute multitude, which can also be called discrete quantity, divides into two species, even and odd. We then have at the beginning of the chapter a simple or common definition of the even number, which is that any number which can be divided into equal parts is an even number. Any number which cannot be divided into equal parts is an odd number. We learn by that definition that the number 1 is an odd number because it cannot be divided into any parts, let alone equal parts. But we learned that the philosophers go into a little more detail. First of all, the Pythagoreans, they explain that an even number is one that can be divided into its greater parts and least number of parts. So what that means is that when we divide the number 10, we divide it into its two greatest possible parts and yet into the least number of parts. And that's what identifies an even number. We learned some other details and ideas of even and odd numbers. Again, the author talks about the number 1 being an odd number, but warns us that Aristotle taught that unity, or the number 1, can participate of both even and the odd, since it causes an even number to become odd and an odd number to become even. And that's pretty much all for chapter 3. So I hope that's a helpful first reading. You see the content of the chapter, what's to be learned in the chapter. It's time for you now to study this chapter carefully on your own for mastery, and complete the lesson assignment to prove that you've understood the content and are ready to move on in classical arithmetic. I hope that's a helpful introduction. God bless your studies.